hi. How's everybody doing here? Great. Cool. So I'm just going to do a quick intro here. So my name is Jackie. I'm actually the team lead for the SDSA AI Platform Lab. So SDSA stands for Samsung Data System America. So what do? We actually provide the IT services, solution, data center, and of course the Samsung Cloud Platform for Samsung itself. Okay, so let me see. Okay, here I'm going to talk about a couple of things here within my team and some of the things that we run into, sort of everyday operation challenges, issues that we run into. So the first one I'm going to talk about is the environment. So what we have is we have a platform that of course, we work with humans, engineers, team members. Along, we also have different compute resources. Of course, everybody knows about GPU, CPU, and memory. Of course, when you have the human working with the hardware resources, you have different conflicts, sharing them, and also different types of scheduling, like job scheduling. And then, of course, the next one is about the hardware, as I mentioned, about the compute resource. We know the cost versus performance. You can buy a really fast GPU, but we all know that they are very limited in supply, not to mention they're expensive, and the lead time for ordering them, that takes months, 6 months. Sometimes we heard actually it takes about a year to get them. And of course, the time for the processing, ordering, delivery, rack and stack in the data center, and also make sure everything is all connected. So those all actually get into the whole environment ecosystem as we talk about how do we share the resource? How do we share all those CPU, memory, and GPU resources? Those are part of the sort of challenges we face every day. That how do we actually utilize the GPU, get the GPU utilization high in that way? I will cover that in the next couple of slides about the GPU utilization part of it. So the next one is about the LLM training. So obviously we know the LLM right now, we are talking about, Llama 3, even with the 70 billion model, they are 140 gigabyte in size. So we do need a lot of storage. And we also don't want to duplicate those storage too, because if there's one engineer using a particular model and another engineer say, hey, I'm using that too. In that case, you're going to double the space. So that part of the sort of a challenge that we run into is storage space, and not just the storage on the server itself, is shared storage, like NFS or some kind of block storage. During the training, of course, the most important part is actually the model evaluation. Because during the training, you have a lot of parameters. You have to measure the accuracy. You have to measure a whole lot of other metrics coming out of it. How do we know this is the model that we're fitting with the data set that we fit in? Oh, also not to mention, of course, for the persistent storage, we also talk about the data set too, because you have your own company data that fits into the model for the training. So we also have to be, if we have to store it in a persistent storage, we cannot put it in a container somewhere that can disappear after the container disappeared. So for the model evaluation, coming back to that, we also have different base model, right? We have Llama 3, we have Mistral, we have different kind of base model, big one, small one, different parameters, different billions of parameters. And then we have different checkpoints, adapters. So in that way that we have to have some sort of a system to storm, and also for the team members or different team to actually pick and choose what they want to use it for, which again, I will cover another slide about the usage part of it. And to kind of conclude all that stuff, we're talking about a kind of like a simple CI/CD pipeline, right? You have the storage that are shared, you have the evaluation, you have different models, and then you have different input, different data sets, and then the output, of course, you have different metrics. How do we measure the performance, the time for the first token to arrive, et cetera, all that stuff. Of course, not to mention you can tweak different parameters for stop criteria. So all that needs to be in a pipeline where the, each team member or engineer, they can do it repeatedly in a consistent fashion, right? So if they actually train a model and they get a really good result, and then they train other ones, but they're not getting, can they replicate the first one so that they can actually ensure that the data set and all the parameters fit into that model training is actually the best one for what they want to do with it. So the next slide is actually about the LLM inference. So we talk about serving the inference here. So this is a output after the training itself. So if you look at this, we have, I have 3 topics here. Serving methods, the costs, and then of course, not to mention the GPU size here. So for serving methods, we all know there are different engines out there, different way to serve it. So you can actually simply just have a Jupyter notebook that actually serve the serve the inference, or you can actually have a wrap around with the API call to it. So that really depends on how the engineer want to use it, how to serve the inference. And then the next one is really about the costs, because we're talking about big model versus small ones. How much memory do we need for that? A good example would be if I have an 80 gigabyte GPU, do we want to put in a smaller model in there where the other memory, half of the memory are actually not being used, but then the other person with a big model, they really need that 80 gigabyte GPU memory. So which leads to the next topic about GPU memory size. Inside an infrastructure, we have different hardware. We have different, GPU, A100s, and then at H series. And then for the A100s, they have different memory size, right? 40 gigabyte, 80 gigabyte. So within that infrastructure, we may have different kinds of hardware in there. So how do we schedule, or how do we assign those GPU hardware to the right engineer so that they can actually utilize the GPU, efficiently and a high utilization rate, right? And then the next one, of course, is really the human part of it, the usage. So there are different preferences for it, right? There's the graphic user interface. People like to click on something and actually see it, different menus. Or some of us, maybe we like command line interface. We probably just prefer a terminal. We can actually, write some code on there and, and then run your code with it, so you can get the actual output or stack trace out of it. Now, of course, after that, the main thing here is logs and metrics. For troubleshooting purposes, we always want to see the log. So if your log is inside say a Kubernetes ecosystem, the person have to kind of type in all the commands and finally find the location of the pod that generate the logs and then get it all out. Or the pod actually disappeared, then the log goes with it. Then you go, okay, so how do I get the logs out of this pod, right? So there are different ways to get that capture, different tools to do that. And then, of course, the other one is the metrics. How do we measure the metrics? What kind of metrics are we looking for? Are we looking for performance metrics? Are we looking for also the profile of the inference or the training? We look at the memory signature and the GPU utilization, all the numbers. And then, of course, the last is the ease of use. If the platform is actually really hard to use, even if we provide all the key feature here, right? The GUI, the CLI, the logs, the metrics, maybe some job scheduling feature, maybe a terminal. In that case, then if this platform is really hard to use, then the user will kind of turn away and they say, hey, I don't want to use this because it's really hard to use. Get the log, I have to type in a bunch of commands just to look at the log. So those are part of our consideration when we look at our day-to-day operation. Some of the pain points that we have every day. So that ties it all the way back to what are we doing, right? What are we doing? We have an office in San Jose. We have a team. We have 2 teams there. So we are looking at 2 different use cases for the different kind of models. As I mentioned, we do different training and also inference serving. The main thing that we're looking at here is the use cases. Are we looking at code generative versus chatbot or content summary? The first two ones here are actually very obvious that your accuracy has to be very high. Because if you generate code and missing a certain block or certain word, you cannot run the code. For the chatbot, it's a little bit more forgiving, right? You can actually say something kind of different, but the user reads it and go, okay, all right. They'll probably say, okay. So also content summary, right? You provide a document and then it summarizes the whole thing. That gets down to where we do the whole CI/CD pipeline. It's, what are we trying to do here is also deciding between large and small LLM with the fine tuning. This all ties back to the cost, because if you look at the large LLM, you need a bigger, GPU, bigger GPU memory, a lot more resources, like I said, about storage, compute resources, versus a small LLM with fine tuning, which you can see the two differences. The large LLM is more for a more generalized purpose, right? For the smaller LLM, we have a more focused usage here. For example, like code writing, generating code. And then with some fine tuning that we actually specifically tell it what kind of code or purpose that we're trying to generate. So the last question here is bigger is always better. Well, the obvious answer is probably not. Because it depends on the use case, what you're trying to do with it. So for code generation, if you want high accuracy, probably small LLM with fine tuning. If you include the cost, also the hardware, the cluster, and the resources, probably small LLM with fine tuning, it's probably better. But then again, it depends on the base model that you're using too. So there's a lot of different variables that we are evaluating. That again ties back to the CI/CDs. We're trying different size, different models, and trying to see which one actually has a better metrics coming out of it. So that's pretty much what I have.
So I think Jackie went over some of the key highlights and the challenges that as he deploy LLMs. Do you want to get any questions, Jackie? Yes, over there.
You're talking about the logs. So since we actually have our own platform, we use a couple tools. So I would tie the logs and the metrics together. So I can name a couple of things, just get you the idea. Prometheus with a couple of those Fluentd agent, and of course when we look at GPU, so we do the actual plugin into the clustered. So that gives us the sort of metrics, right? The profile of during the training, what kind of memory, what kind of resource that you use. For the log, we used ELK before. Probably skip out the L, but just the K. But K is more for the UI. But it's a little bit more heavyweight for what we're trying to do. So yeah, so we also evaluate different tools also. So we're not tied down to that. We're only using that particular tool, right? Well, so obviously the first one is definitely any errors. So when the training exit early, we also want to look at what caused the stack trace and what happened, what went wrong. That's more for troubleshooting. If the code or the training actually exit early. But for the metrics, that's a little bit more time consuming because we have to sift through the actual behavior. Because at a certain time, if you look at the training, certain part of the training itself actually doesn't really use the GPU. So for example, like the data set, the cleansing part of it, it really is just use the CPU and memory. And then finally kicks in, then you use the GPU. So we also need to profile that behavior there too. So we can actually make a couple of things I mentioned about GPU utilization. How do we make it so that, when we assign that particular resource to you, we know that you're only using the GPU for a certain time, but during that time, can we actually give it to somebody else to use it, right? So we can keep the GPU utilization high during that time without causing any conflict, of course, right? So I'd categorize in two groups here. One is, so if I have to use, say, SQL generation, for example, One is obvious that the SQL query itself is completely wrong, meaning you fit it through a sample database. You just, the database just give you an error. So there's syntax error or it's missing a certain, condition in there. It just doesn't work. The other categorize is, the query runs, but does it give you the right result or the expected result? So that's where we have some validation coming in, right? So it generated the result, it generated the SQL query as the result from the model. But if we run it through the database, does it give me the number that is expected? So that's our sort of a quick check on that part.
Thanks, that was super interesting. I wonder if you could tell us a little bit about why you decided to go down the fine-tuning route rather than using off-the-shelf kind of proprietary models that are state-of-the-art, and how you would intend to kind of keep on top of things like schema changes to your database with fine-tuned models which are locked into a particular schema that they've been trained on.
Actually, a very good question. I don't think I have a real answer for that one because, as I mentioned, we're also testing and evaluating different models. But for the first start, we do take it off from the shelf as a first look at it. It's like, okay, for example, we may run through some spider benchmark, a database again related to that. We may want to take a first hit and then see, hey, if we run through that, what's the accuracy on that one? Or we give it a couple more shots to see if the accuracy actually drops or goes up. So we do our first kind of sort of eyeball tests on it to see, hey, what kind of number are we getting out of it? If we get some really bad numbers, then we say, okay, we're not going to do that. Then we look into, like as I mentioned, do we use that and fine tune it furthermore? But then we don't want to fine tune it so that it become overfitting. That is so sensitive that you change a little word and the whole thing just goes off, right?
Hi, obviously GPU resources are scarce. How do you manage GPU scheduling between different projects competing for the GPU resources?
Oh, okay. So that's actually it's not an easy question too. I mean, it's easy answer for that one too, because we are running into that problem almost every day with our platform too. We have the resource or the GPU resource, and if you look at the utilization, how do we share in a fair way, right? So I don't know. I mean about other, but we really look at the allocation. So if we allocated a certain GPU for a certain team, then they have that certain sort of allocation, kind of like the not on demand, but the reserve instance kind of thing. But instead of instance, more like GPU. So you have that allocation for that particular team. But yeah, it's very it's also one of our challenges. We're trying to solve the GPU utilization because there's different teams, different numbers. They use different, as I mentioned, there are different ways to use it. They do different things. They can use a terminal or they can do a job submission. So that is also a problem that we're trying to solve too, right?
Last question.
So I have a question regarding when there's only a very limited amount of data. So in the case that the targeted domain is different from the general domain that the language model is trained on, and there's only a few samples that are available, do you recommend doing a few shot prompt engineering, or fine tuning on smaller models, or fine tuning on a larger model when compute capacity is not a constraint?
Actually interesting. I actually had a meeting with my team and the other team talk about something similar to that. So what we found, as I mentioned, the overfitting problem. So we trained. So there was big, large model versus the smaller one with the fine tuning. So we have to be careful on the fine tuning because if we fine tune it too much, it becomes overfitting, which is a problem. Yet, if we use a large model, we realize not only the resource that actually it requires to run the large model, but also the response time for the inference. When we serve the inference, that becomes actually a in a range where I would say as a user they probably won't accept it, that they have to sit there and wait. So I mean, I don't think I have a definite answer, but you have to consider also the response time of it. versus the accuracy for a small model versus LLM, but then we also be careful not to overtrain it so that it become, or overfitting it become a problem, right?